Hello, the title of the project is Hybrid Power Flow Management in Fuel Cell Vehicle. The need for the project. This slide addresses the shortcomings of conventional IC engine vehicles and electrical vehicles. Proposed solution and objective. The primary objective of this project is to increase the range and decrease the charging time of a conventional electric vehicle. These are the main powertrain elements in the electric vehicle that the project has been done on. Methodology. This project is carried out in a methodology that contains three modes. In the first mode, the battery is a standalone power source that propels the vehicle. In mode 2, the fuel cell is the power source that propels the vehicle as well as charges the battery. Mode 3, both power sources are combined to propel the vehicle. Design implementation. This is the Simulink representation of the mode 1, and this is the block diagram representation of mode 1. This is the Simulink representation of mode 2 and the block diagram representation of mode 2. And this is the third mode and its Simulink representation and the block diagram of mode 3. So in the design of the DC-DC converter, the converter uses a MOSFET as a switching element and inductors and capacitors as energy storage elements. Pulse width modulation is used for switching operation of the MOSFET. Given here is the circuit diagram for the converter layout. To design the DC-DC converter, certain calculations are required. These are the given data for the calculations. The calculation of duty cycle and loads. The calculation of inductor value. And finally, the calculation of the capacitor value.
So we are having a 6 volt 4.5 amp hour battery. So this battery is connected to a circuit board which is designed for a boost converter consisting of inductor, a Schottky diode, MOSFET and two capacitors and a load resistor. The inductor value is 500 mu h and capacitor is 200 mu f, and we have a MOSFET of IRF Z4NN MOSFET. So this is the our setup, and in order to give gate pulse for the switch, we'll be using a Arduino Uno, where we have written the code for the sending the PWM signal according to a required frequency. The frequency which we are using is 62 500 kilohertz at a voltage of 5 volt peak to peak voltage. So this black wire is the black wire is the PWM signal which is given to the MOSFET in the circuit board, and this is the common ground for the Arduino board. And Arduino board is powered by a 6 volt AA batteries, which is given to the common power supply in Arduino board. And we have connected a 12 volt fan connected with it with the output of the setup. So now we'll be running the setup and we'll be seeing the results in it. So initially we'll be checking the battery voltage using a multimeter. So this will be. Yeah. So this is the battery voltage. Both the multimeters are connected to the battery, and we can see the battery is having 6.41 volt, 6.4 volt on an approx. So this is the under OCV condition. This is under no load condition. So now what we will be doing is that we'll be connecting to the main circuit with a PWM signal given inside. So now let's connect it.
அடுத்து வந்து if you increase the duty cycle then the voltage will increase னு சொல்லுது.
Now in the Arduino we have currently used 50% duty cycle, that is from 6 volt to 12 volt. If we want more voltage in the system, let us say for example from 6 volt to 24 volt or 25 volt, we can increase the duty cycle in Arduino depending upon the requirement. And if we increase the duty cycle, you can see we can increase output voltage also. So this is the final voltage of the circuit.